Hi, guys. I'd like to demonstrate an example in Chapter 2, number 3 in particular, involving some simple probabilities, and that included in my list of WebEx videos to help solve all the examples that you're assigned in homework. And there for the test, not all of them, but the more difficult ones. Let me share my screen. And we're going to go to Chapter 5. I'm sorry, Chapter 2. Where does this in the chapter? I'm pretty sure it's Chapter 2. Homework number 3. Nope, that's not it. Number 3. Okay. So this is very straightforward until the very end. So let's go through this systematically. What percent of the companies reported a positive change? Well, over 52 weeks, it was 5 plus 9. These are the companies that had a positive change over 52 weeks. Out of a total of 5 plus 9 plus 10 plus 16, which is equal to 14, 24, 34, 40. So it's 14 out of 40, which I need a calculator for. That's 35%, 0.35, which is 35%. And we'll do this quickly. What percent of the companies had a positive change over both time periods? Well, these 5 were in this row and this column, which is the intersection of these two categories, sometimes called variables, and this what's called a 2x2 table, which we're going to learn about more in Chapter 5, but this 2x2 is a very basic way of summarizing information around 2 categorical variables. So it's 5 over 40, which is 1 out of 8, which is 12.5%, if my memory serves me correct. Yes. What for both negative? That was 16 out of 40. 16 out of 40, which is twice as much as 8 out of 40. Let's see, 16 out of 40 is so I should do that in my head. I'm embarrassed. Let's not get it wrong. 16 divided by 40. Whoa, 16 divided by 40 equals 40%. What percent of the companies reported this over one period and then a negative over the other period? Well, that's these 9 were negative, then became positive. And these 10 positive became negative. So it's 18, it's 19 over 40. 19 divided by 40 equals 40.475. Move over the decimal, so it's 47.5%. Now this is an interesting question. It's called a conditional probability, which we're going to learn about again in Chapter 5. Among those companies reporting a positive, what percentage reported a positive over the prior year? So recent day changes, these 15 companies we're talking about, among those 15, conditioned on that, how many had a positive change over the prior year? So it's 5 out of 15, which is 33.3%. Another conditional among those companies reporting a negative change over the recent day, which is these 9 plus 16, or these 25. How many had a positive change over the prior year? So it's 9 divided by 25, which is 36%. Now comes the hard one. What relationship? Now, again, this is hard to explain without introducing the formula from chapter 5, but it's really the best way to do it. The way you understand if something is related, if two variables are related, namely the recent day change, does it have an impact on the prior 52-week change? Well, let's figure out the probability of just one of them, namely 52-week positive change, which we said was 5 plus 9, which is 14 divided by 40, which was 35%. So that's, if you know, without knowing any further information, you would say it's about 35%. What if you knew further information? What if you know, for example, that there was a positive change? So you know something about the other variable. Is that going to change things dramatically? Well, among those with a positive change, it was 5 out of 15, we just said, or 33%. And since 33%, which was this answer, I'm sorry, what was that last answer? Hold on. Did I get this wrong? Hold on. What? Those are, we're going back now. Among those reporting a negative change over a recent day, which is, I'm sorry, this was this one over here. Anyway, we said among those with a positive change, meaning over a recent day, it means among those 15, 5 out of 15 or 33%. But if you ignore the other variable, just how many people had a positive change ignoring the other variable? It was 14 out of 40, which was 35%. And since 35% and 33% are very close, it seems that knowing something about the other variable does not really change the probability. So I would say the answer is there does not seem to be any relationship. And if I'm wrong, and we're done here. So I'm going to close this out, leave, stop sharing, and X out of here.